we are going to look at the process involved in the formation of our solar system. And the beginning point of the process is you start with a large cloud of gas and dust. And observationally, we know this is true because we can see stars forming in clouds of gas and dust. Those clouds are called nebulae. And we can actually see stars in the formation process inside those clouds. And what triggers star formation is gravity, because gravity is going to cause that cloud to collapse. And as it collapses, because these clouds are not completely stationary, they have a little motion, that rotational motion is going to get faster, very much like how when an ice skater pulls in their arms and they spin faster. As the gas cloud gets smaller, it spins faster, and that fast motion develops a disk. Sort of like tossing pizza dough. You start with a round ball of dough, and as you spin it, it flattens out into a disk. At the center of the disk is ultimately what's going to turn into our sun. This we see when we look at star-forming regions elsewhere. We can see the stars forming, and we also see many of them surrounded by a disk of material. Now within that disk, material is going to start to clump. And the official name for that is accretion. So what's going to happen is you're going to get concentrations of material. And again, this is gravity at work because it is pulling material in to each one of these little clumps and building up. It's sort of like a snowball process where the material starts small but keeps accumulating more and more material. And so part of the process, it's making our little clumps get bigger. The other part of the process, as we see in the next image, is it's starting to clear the disk. So our disk is getting less gassy and dusty. Our clumps are getting bigger, and eventually, as you see here, each of the orbits, there's material all around. Eventually all of that material accumulates and we have our planets, and the orbits are relatively clear. Now it takes time, and what happened in our solar system is that that material that was strewn along the orbits, some was there for quite a while, and that resulted in a lot of collisions even after the planets formed, which is why we see a lot of craters on Mercury and our moon. It's probably where our moon came from as the result of a very large piece colliding with the Earth. It may even be responsible for the fact that the planet Venus, although orbiting in one direction around the Sun, spins on its axis in the opposite direction, and that could be the result of one of these collisions during this era of collisions early in the solar system. Today, The orbits have been cleared pretty much of all of the remaining debris, and so now collisions are much more rare, other than stray asteroids and comets heading our way. But this general process is essentially gravity driven, and that is how our solar system and planets came to be.